Welcome. This is Sarah Meisel, and I'm doing my Greenbelt Lean Sandwich Shop presentation. This is our sandwich shop. So our problem statement today is every day the Lean Sandwich Shop employs 12 workers to make an average of 600 sandwiches. Each day, 10% or 60 sandwiches are wasted due to poor quality of ingredients. The order is wrong. This branch is at risk of closure due to a worsening reputation and revenue loss. Our goal statement is through simple changes and a better process, the new Lean Sandwich Shop can improve quality, revenue, and reputation. How do we identify issues? Where do we start? How can we find a root cause? These are good questions, so let's look at some helpful tools. This is a Scrum board, and over here we have this tool helps us map out necessary tasks to contribute to finding the root cause of the issue. Our example is in the done observation, right here, boop, we are observing takt time for sandwich shop production. So when we observe the takt time, we can check that what we're doing and how long it's taking to do such things. That's what our observation takt time is going to be for, but that's in our done pile. So in this tool example, we're following our goal statement. By following our goal statement, we can look at the critical to quality measures, and those things will be quality staff, boop, quality sandwiches, and efficient delivery. The critical to quality tree helped identify the areas of focus where data can be compiled. So to get quality staff, we will need manual time observations to find out what can be improved upon. To ensure quality sandwiches, we need to assess the current state and build a push and pull system for ordering lead time so that we can get fresh ingredients all of the time. We need to figure out what that lead time needs to be. An efficient delivery. So we need to make sure that our cycle time is efficient. Taking 10 minutes to make a sandwich is a little bit long. So these are our manual observations, manual time observations. So this is an example, and in this example, we specifically look at the tasks of employees toasting sandwiches. We can see that observations with the highest times had an employee talking with another employee, distracting them from noticing the toaster being finished. We also see a distraction where the sandwich is not immediately removed. Because a major concern is burnt or cold sandwiches, this is where we will focus on improving our process first. One thing we can do is add a timer to the toaster so that you hear when it is done. That's one solution. So with our manual time observations, we can make a work combination chart, and that's what this tool at the top here is. You can see this here, this brown bar, is the amount of time a toaster takes. It takes 145 seconds. So by using our findings from the manual time observation, we can create a work combination chart. In this chart, we can see a major opportunity for process improvement and cycle time reduction. The sandwich toasting takes 145 seconds. To appropriately use takt time, we need several employees at the toasters to ensure efficiency. However, much of that time is wasted on waiting for the sandwich to toast. This leaves us with a task in which several employees are standing around waiting. If we can utilize that time better, we could reduce the overall cycle time. This is an opportunity here for value-added time because we're just waiting. So this is our value stream map. Our current state is mapped in this value stream map. This map shows the current lead time for ordering and the time for tasks. Our lead time is 5 days and our process time is 600 seconds, meaning it takes 10 minutes to make a sandwich. And this shows all of these things, process 1 through 7, all the different little pieces to make the sandwich and how long it takes to get to the whole 10 minutes, creating 600 sandwiches. And then we have the daily, 3-day, and 5-day different ordering, what is coming in on those days. Kanban. Part of the problem with the way that our food is getting there is that it's constantly being ordered and we don't know exactly what will be there when. So in this scenario, we want to look at a Kanban system for ordering that will create a push and pull system, reducing accidental overages or shortages on all supplies and ingredients. This system will reduce lead time and give us just the right amount of each item so that we always have the exact right amount on hand. This example is to look at wrap boxes, and this is the equation to figure out how many we need. So we came up with 11. We need 11 on hand in this scenario with this to make sure that we're always having the right amount and we're not running out. We're always using it. We don't have too much, not too little. Cycle time. Each task in building our sandwich adds up to a total of 600 seconds or 10 minutes. Currently, it takes 12 employees 10 minutes to make a sandwich. With our manual time observation, value stream map, and work combination chart, we're able to input data into our work balance chart. This will help us identify how many employees we truly need. Our current TPH is 5. With reduction in cycle time and in staff, we can increase our TPH. The better our TPH, the more efficient our sandwich shop is running. TPH is how many sandwiches are made per person per hour. So if we have 10 employees, 12 employees, right, and our TPH is 5, that means each employee is making 5 sandwiches per hour. That's what TPH is. So here's our work balance table. How do we decide how many employees we need? With a work balance table, we can balance the tasks to match our takt time. In this case, it's 60 seconds. Look at this beautiful, beautiful, beautiful. 60 seconds, 60 seconds, 60 seconds, 60 seconds, 60 seconds. But as you notice, there's only 5 bars here, not 7. There was 7 tasks. So with our work balance table, we can balance the tasks to match our takt time, right? And that's going to be 60 seconds. In this chart, we have been able to identify areas to reduce our overall cycle time. Tasks 2 and 3 are combined for efficiency, and tasks 7 and 8 are as well. Let's get a little closer look at that. So on our work balance table, after making the cycle time adjustments from our current process to our new process, we can estimate that we only need 9 employees. This increases the TPH from 5 to 6.67. So instead of making 5 sandwiches per hour per person, we are making 6.67 sandwiches per person per hour. Here is a better look at this breakdown. So task 1 needs 2 employees, 120 seconds, 60 seconds per takt time of 60 seconds. That's how we balanced it with our work balance table. And to give a little more insight to that, task 1, we didn't improve the time it took to do that, but we just added a little bit more of a responsibility that was from task 2, which is grabbing the bread. And then task 2 and 3 combine tasks to reduce extra employee, reduce the time by 45 seconds. No time improvement to task 4, just a quality check. Task 5 is improved by the task 5 employees helping the task 6 and 7 employees. So that's the toasting employees. So instead of waiting around for the toasters, they're helping wrap and deliver when appropriate. And then task 6 and 7, it was improved by 30 seconds by combining the jobs and getting help from task 5. So instead of wasting all the time on the toasters, the people at task 5, they're listening for the toasters, but in that time, they have enough time to go wrap a sandwich or do another task. So value added time, that's what we're talking about with task 5. By reducing the total process cycle time from 600 seconds to 10 minutes down to 540 seconds or 9 minutes, we gain 10% of 10% or 1 hour a work day of value added time. So that's a lot more time. This is how much time we were using. This much already is saved just by reducing our cycle time. So here's a look at some recent TPH recorded in our observations. Our upper control limit is 4.49, which is kind of low, and our control limit is at 1.37. This is an example that falls below our average of 5 TPH. And this observation, you can see we're far from our goal of 6.67, meaning the shop is struggling. So we've talked about a couple of things that helped us identify the problems. Now let's talk about solutions for improvement. We can streamline the sandwich making process, creating teams for making the sandwich in phases, reducing our overall cycle time. And we already saw that we can reduce that down to 9 minutes. Each team is responsible for ensuring the quality of the sandwiches and ensuring fresh, correct ingredients. And if we create a push and pull system for ordering, we can reduce our lead time inefficiency and ensure all ingredients are freshly available as they are needed. So let's look at the standard work chart. What's a standard work chart? This chart introduces a design layout called a work cell. The standard work chart helps employees know their tasks and expectations. Let's look let's take a closer look at this work cell. So this is my design for our work cell, and it's on this standard work chart. This is what we would give to our employees so they know task 1, 2, and 3, these tasks highlighted by these jobs, that is their job, is to ensure that these things are done. So this just helps make everybody accountable and know what they need to be doing. That's our standard work. This is our work cell. So this is my design for the Lean Sandwich Shop. We get our customer here, we get order person here, They're grabbing the bread and giving it to the protein person. That's our third task. And then we have our task 4 and 5 are here. Our person, these two people, are helping with task 4. They're putting the veggies, sauces. Then we have 3 different people on our toasters. And when they put something in the toaster, they know they have 145 seconds, so they can run to the wrap station. It takes about a minute to wrap something. If we reduce this time, they can help here, and this person can make sure the wraps are picked up and delivered, and they're always wrapping and delivering, wrapping and delivering. These people are toasting, and when there is time waiting, they can help out here. So a little bit better explanation of that. So we have our work task cell breakdown, right? We have all the different tasks, and you can pause and read it if you're interested. It just breaks down what each and every task is. So a little bit better explanation is by assigning teams to the shared tasks, staff can help make more sandwiches quicker to ensure quality. Think back to our standard work chart. Everybody knows what their job is. Everybody knows what that team's job is, so that it makes it a little bit more efficient. So team 1, that's our order taking, selecting the bread, and adding protein. Team 2, keep in mind, this is only the people adding the veggies and sauces. They're adding veggies and they're checking for quality. Team 3, they're toasting, wrapping, and delivering. Each team has different checks to make sure that everything has been done correctly. So team 1, we got our order people, bread people, protein people. Team 2, our veggie people, and they're checking for quality, making sure the stuff they're being handed is good, the stuff they're adding is good, and they're sending it off to be toasted, and everything looks correct for our customer. Team 3 is toasting, wrapping, picking up, toasting, wrapping, picking up in a circle. However, they can be helpful. There's probably always someone at a toaster. There's probably always someone going back and forth between wrapping and someone helping the order picker-upper person. So let's look at some risk. Our risk assessment matrix. This allows us to call out known risks and give them a rating and implement a countermeasure to ensure that the risk is reduced. The biggest risk identified was incorrect vegetables and toppings applied. This goes back to our making sure we have quality sandwiches measure. So the countermeasure is to parrot the customer. So if they're always putting on, or often, the problem is that their incorrect vegetables and toppings are applied, one way to counter this is to parrot the customer. So that means the customer says, oh, I would like this vegetable, and you say, this vegetable, and you make sure that you are repeating it so they can say yes, so that you're getting for sure the right ingredients. It's reducing the risk of accidentally adding the wrong thing and wasting. And remember, our waste is at 10%, which is really high. So the more we can reduce this, the better. Our score there was 27, and our new score is 2. By parroting back, we are ensuring that we are getting the right answer more often than not. So team 2 is comprised of only 2 employees, that's the vegetable people, and their primary goal is to make sure that they are really focused on, yes, this ingredient, so that we're not having to remake anything. Real quick, another one of the risks that we reduced was the toaster, right? If there's a timer on the toaster, then we can hear when it's done. There's 3 people, there's always someone to be putting something in the toaster or taking it out and helping wrap. So that increases our efficiency there. That was reducing one of their major risks, which was sandwiches that were burnt or cold. We don't want either of those. We want nice, perfectly toasted sandwiches. All right, so this is our cost of quality. The cost of current inefficiency is enough to potentially close this location and harm the reputation of the Lean Sandwich Shop franchise. The main problem is that this location is losing a minimum of $750 a day in opportunity costs through wasted food scrap and excessive or inefficient labor costs alone. This totals to over $273,000 of lost revenue over the course of the year. And for math's sake, I calculated that it would cost $5 in materials at 60 sandwiches a day. So if we look here, we can see an average, it would take an hour a day is wasted at $15 an hour. Cost of task, I didn't put anything there, but the cost of materials, again, I did half the cost of a sandwich. If they're $10, $5 in materials, so that's causing $300 here. And then the payroll efficiency, 3 hours, so from 12 employees to 9, that's 30 hours a day at $15 an hour, that's $450. We add that together, we get $750. Multiply that by a year, 364, we get $273 in lost revenue. That is insane. So if our goal is reducing excessive employee payroll and food waste scrap to just 5%, we would increase our bottom line by $350,000 and give an ROI of $5,187 to $1. This is pretty impressive. So labor hours alone, if we remove the scrap food and we just look at just the labor hours, reducing from 12 to 9 and a TPH of 5 to 6.67, we are saving an annual $163,998 in lost opportunity. That alone will keep the sandwich shop probably in business. So here we go with our control plan. Okay, we talked about all these changes we can make. They're really simple, really straightforward, but what happens afterwards? So once change is implemented, how can we ensure the problems do not begin again? This control plan shows the plan of action to keep changes made effective. So we have audit task 1, task 2 and 3, task 4, task 5, task 6 and 7, right? Or 5 through 7. These are when we're going to need to be really paying attention. So we want to remain 90% effectiveness, and we want to check that by checking our attribute gauge R&R. So we're doing that weekly in our statistical process control. In the first fail in 4 weeks, we need to retrain staff to make sure they understand the new process and they understand their standard work on their teams. The second fail in 4 weeks, we're going to have a 30-day probation. We really got to make sure we're staying on top of this. But this control plan helps us know that that's what we are doing. And if we get out of control, we know there's areas that need to be improved upon again, and we'll just go back through the same tools. All right, and if you have any questions, be sure to email me them. Thank you very much.